Hey guys, welcome to the Cozy Gamers channel. My name is Aaron, aka the Cozy Gamer, aka the Cozy Programmer now, I guess. So anyway, as you may or may not know, probably wouldn't know because this is my first video. Um, I am a computer science major, and so currently we're working on Python. It's our first computer science class because I just started this class, um, and it's a lot of fun. But we have had an extremely excruciating uh, program that we've had to write called Card Game. If any of you guys happen to go to IUPUI and happen to be in a computer science course, you'll know the frustrations of the program, Card Game. So this video, the purpose of this video is to give you guys a deeper understanding of how arrays will work, so that way you can use these because arrays are used for just about everything. They're used for holding data and being able to call for data. And so it's critical that you figure out how to use this, because if you do, you'll be a great programmer. If you don't, you're not going to be a programmer, period. So anyway, let me give you a brief explanation of what this does. So, as you can see in the comments here, it's a basic card game framework, keeps track of card locations for as many hands as needed. So that's nice. Basically, what this does is this game kind of gives you the framework for a basic card game. And what it's supposed to do, as you can see over here, is it prints out the all 52 cards in a deck, the name of all 52 cards in a deck, or the number of each one. That's not really anything that impressive, this numbering here, so don't worry about that or get hung up on that if you can't do that. Um, and then it shows where it's assigned. So as you can see, the first few ones are deck here, and then this one is computer, so this one got assigned to the computer, or dealt out, I should say. This one got dealt out to the player, these got dealt out to the player and computer. And then we're also displaying just the player's hand and just the computer's hand. So how does this work? Well, the beauty of this is, and what the focus of this program is around arrays, like I mentioned before. So let me show you our local variables here, or our global variables here, sorry. So we have num cards, which is equal to 52. This can be changed depending on the type of game you're using. If you're using something like Euchre, which uses less than all 52 cards in the deck, it's nice because you can just go in here, change the number of cards, and then you still have a fully functioning program. If you want to change the number of players, you can just add another player variable, or however many player variables you want, and then change where they're assigned to, and then it'll spit out cards for as many players as you want. And then we have this array right here called card location. Now, as you can see, card location is equal to an array with a single element of 0, then it's multiplied by the however many cards you have. So, for example, in this one, we have 52 cards because there's 52 cards in a deck. And if you look up here, you'll notice that I printed out an array with a bunch of zeros in it. But, oh look, there actually happens to be a 2 in there, and a 1 in there, and in fact there's a number of 2s and 1s. And if you'll remember, player is equal to 1 and computer is equal to 2. Huh, curious. Maybe that'll be important. Well, you would be right. So, let's go and look through our main function right here. We've got a function called clearDeck. This isn't anything super big, but it is useful in case you have your program loop back around to the start and don't just close the program and restart. You will need this. Then we have, for this program, it wasn't actually necessary that this is in there. In fact, I could have just completely left this out, erased this, if I was allowed to change the made code, but I wasn't allowed to change anything above here. But anyway, I could have just erased this, and it would have been fine and still worked. But if you want a program that goes back around and restarts itself, like you have a start over function or something like that, then you definitely do need this. That way, you'll get a different random assortment every time you run through this main code here. So anyway, clearDeck, all that does is just resets every number in the deck to 0. Now, here's where things get interesting. We need to take all of these, and we need to assign a random number in card location, because remember, card location is equal to the number of cards we have, so that's going to be important. We need to assign a random one of those to a random player. So if we had different players, we could assign more cards to more random players. Um, but basically, let me go through this. So we have the parameter the player here, and this could be anything. In fact, I could put junk there, and if I just changed this to junk, it would still work just the same. All that this is doing is taking whatever parameter you throw into it. In this case, it would be player and computer, which is, remember, if we remember, that's equal to 1 and 2 respectively. And then it will just spit out whatever you put back in here. So don't forget the scope of variables. If we put a parameter in here, then its value is only going to be defined within here if I type it in. So that's the player only has scope within this function right here, and the player won't be defined outside anywhere unless I write it again, which I did here for clarity's sake. But anyway, this function, assign card, basically is responsible for dealing out the cards to the player, if you will. So let's take a look at this function and break it down. So while true, well, what is while true? Well, while true basically is just an infinite loop. We don't have any anything that while what is true? Well, while true is true. So basically what this while loop does is it just loops an infinite number of times. Well, Aaron, what's the point of that? Why would you do that? Why would you want to do something so evil and so malicious that you have it loop through 1,000,000 times? Do you make viruses that just eat up people's hard drives and destroy their memory? No. Because if you look down here, 2 lines down, well, 3 lines down, I have this thing called break in here, and break will stop whatever the while loop is doing. So, let me go through the contents of this while loop. So we have wildcard here, which is equal to choice, and choice, as you can see up here, I imported the random module. Choice is part of the random module, so all choice does is it takes a selection from a range that you give it. And in this case, I gave it the range of the length of card location. So if card location, which remember is dependent on num cards, is different than 52, I don't want to put in 1 through 52, or else if I wanted to play something like euchre again, and I set it 1 through 52, then it would assign, it would be off, and it would assign to numbers that don't exist within card location. So if card location with the index location of wildcard is equal to 0, so just because excuse me, wildcard doesn't have to be, this isn't talking about a physical 0 in here, because as you can see we have a lot of zeros in here, but what wildcard does essentially is, or what this index does here, I should say with these square brackets, is it basically says if this index location, which you randomly generated, so let's say the 5th index location is equal to 0, which it was because we cleared the deck at first, but this is just printing out the result of what assign card had done. So if card location of wildcard is exactly equal to 0, then we break the while loop. Okay, so it stops going through the while loop. So this means is if it checks and it's not equal to 0, so like let's say it goes back and it generates 5 again and finds that, well, the 5th element here is not equal to 0, it's actually equal to 2. Well, then it's going to go back through the while loop again until it finds somewhere that is. That way you don't get duplicates, and you will get it to deal exactly the number of cards that you want. So then if that happens, then we'll break. So we'll stop the while loop, and then we'll say, okay, so wildcard, that number we just generated, so it was the 5th location. So the 5th location, right, we'll set that equal to whatever the player is. That way, if we've got multiple players, then we can assign it like 1, 2, 3, 4, 5, whatever we need to pass. So that way we've got player 1, player 2, player 3, whatever. But this will change that number equal to 2 or 3 or 4, depending on the number of players you have. And it does the same thing. So for the first time when we set assign card equal to player, as you can see for like say the 20th element here, it sets that one equal to 1. Okay, now here's where the comparison of arrays comes in show deck here and show hand. I will explain show hand because it's a little bit more concise, but just keep in mind the same idea is in show deck. It's just a little bit more unwieldy because I couldn't change this main code here. And so show deck it wasn't passed any parameters, so I couldn't just set if card lock is equal to the player like I did here, or like I did here. Show deck just shows the entire deck, so as we see here. So I just had to say if it's equal to 0, print this. If it's equal to 1, print this. If it's equal to 2, print this. So I'll explain that, and that'll make this a little bit more clear, and you'll be able to understand it. So basically, in show hand, we have this variable which I set equal to, I made a comprehension out of it and turned that into a list. So rank of suit for suit and suit name for rank and rank name. So it basically takes these two and combines them and gives me a list of all the possible combinations of ranks and suits here, which in this case is 52 ranks and suits, or rank suit combinations, I should say. So this gives me all of the potential cards in my deck, right? So if we wanted to, let's say we wanted to later change this, so for like a euchre deck, we don't need anything. We don't need the 2, 3, 4, 5, 6, 7, or 8 cards. We only need the ace, 9, 10, jack, queen, and king for a game like euchre. So we could just erase these from rank name, keep suit name the same, and it would give us the same. It would give us the desired output, which is just ace, 9, 10, jack, queen, king. So yeah, if you are writing a program, you want to write a program in such a way that you can easily modify these variables up here or add more variables and add more of the same function and not have to change the functions at all. If you're having to change the functions, you're doing something wrong. If you're able to your best program is the best program is the program that can just have more variables assigned. You can add, in fact, you can add as many variables as you want, or change as many variables as you want, without having to change the functions. So in this case, as we can see here, if we added more players, because we didn't pass any parameters to show deck, if we added more players, show deck would stop working. Or show deck wouldn't work correctly because it wouldn't show the location of, like, let's say player 3, because I don't have anything defined for player 3, so I'd have to modify this function and add more in. Now, if I could modify this, I would do something like, say, show deck player, and then I just copy and paste that and do show deck computer, show deck deck, and then you could do show deck player 2, show deck player 3, show deck player 4, whatever. And then all I'd have to do is do show deck and then do the player. And then I could set this equal to the player. And then I could just get rid of these two elif statements. And then I would change this to curly brackets dot format the player, and then it the player, sorry, I've got an array here. Player name the player. So what that does is it'll take whatever this number is here and give it the location here. So since remember deck is equal to 0, so I pass in the parameter of deck and it's equal to 0, so it'll take 0 and then it'll format this so that it prints out the 0th location in player name. And we have player name defined here. So the 0th location in player name is deck. So it would print out I plus 1. That's just so it doesn't start counting at 1 because computers count weird. Or it doesn't start counting at 0, excuse me, because computers count weird. They count from 0, and it'd go from 0 to 51 instead of 1 to 52. But basically, it'd take so I plus 1, and then the card for that location, print it out, and then format it so that'd be player name the player. But unfortunately, I couldn't modify this, so I couldn't do that. But just so you know, you can do something like this, so you can get it to print out whatever you want. Actually, I'm just not going to save this, so I won't mess with that. Okay, so then show hand here. So in order to compare these two lists, what I did here is I used this, which is a print, and then I did some more formatting. As you can see, player name of the player. So this one works just easily, so I could print out as many players as I want, as long as I have the amount of cards, the right amount of cards for them. Because if you don't have the right amount of cards, and then you run through this while loop here, it'll keep infinitely going because there'll be no cards left equal to 0. So it's essentially like you're trying to deal out cards when you have no cards left, is what would go on there if you have more cards to deal out than you have cards in your deck. So you'd need to change num cards to accommodate for that. So we have show hand the player. Cards is equal to rank of suit. Okay, so we have the same list up here that I used up here, down here. It prints out that name, and then it says for I in range length of card location. So we want to set this equal to card location for the same reason I set up here, so that if card location's length changes, we're not left with 0 through 51 for, again, like a game like Euchre or something, but we have an appropriately long range that we're pulling from. So for each iteration in range length of card lock. So on the first iteration, I will be equal to 1. In the second iteration, it'll be equal to 2. Third, 3. Fourth, 4. Fifth, 5, and so on and so forth. So if card location of that specific iteration is exactly equal to the player. So what this does is this says, all right, let's look through here. Let's say we're on iteration number 5. So it goes through, okay, let's say if card location in iteration number 5, so I is equal to 5 right now, so if card location in the 5th index location, right here, is equal to the player, and let's say we're on show hand computer right now. So if show hand comp, player is equal to the comp right now. If card location I is equal to computer, which it is, it's equal to 2. And remember that comp is equal to 2. Then print cards and then the index location, or the whatever is in the index location, the 5th index location in this case, of cards. So in the 5th index location of cards, we have the 5 of hearts. So if we look down here, what's the first card in computer's hand? 5 of hearts. So as you can see, that's an easy way to be able to compare the two lists. All you need to do to be able to compare two lists is 3 lines of code. That's it. An iteration, an if statement, and a print statement. And if you wanted to do more with this line would be different. It may be multiple lines. But if you wanted to do something with this information here, all you need to do is you need these 2 lines here. And then you can play around and do whatever you want with these lines here. I don't really know any examples of what you could do with this. All I did is just print these out. But if you wanted to like add something to it or do some math to it, then that's what you would do in this workspace here and below. And then as you can see, we run the main function, and that does all this and runs all these. So yeah, that's arrays and how to work them in Python 3 in a nutshell. So I hope you guys really enjoyed the video. If you liked it, give it a thumbs up. If you think that there's anything that I can change or do better, please leave a comment in the sections below. I know I may be a bit wordy and stutter, and this video is a bit long, so please just give me any sort of constructive feedback that you guys like. If this video helped you, please let me know. I'd love to know what you guys liked about it and what you guys are looking to know. And as I learn more, I'll share and upload more videos with you guys. So thanks for watching. You guys have a great day. And remember, stay cozy. Bye.